All right, welcome back, students. In this video, we're going to cover lesson 5-7. This will finish up module 5, triangles in the coordinate proof. We got two standards below the title. On the left, it reminds us the distance formula. We got that highlighted, and the slope formula. Both of these are on the reference sheet for the EOC, so no need to memorize, but those are there if we need them. Just gonna do a couple of things here. Let me scoot in a little bit. So over here, our key concept: placing triangles on the coordinate plane. So these are some rules that if we're gonna go mark our own triangle on the coordinate plane. So number one, use the origin. So this right here, as either a vertex, as they did here, or the center of the triangle, and that's what it looks like down here. See, the origin's in the very middle of the triangle. Number two, put at least one side of the triangle on the axis. So see, this one's on the x-axis. Down here we're on the x, and then we have an example below that's on the y-axis. Number three, keep the triangle within the first quadrant if possible. They did that here. Here, when you put it in the middle, it's not all within the first quadrant because you're using the origin as the middle or the center of your triangle. Number four, use coordinates that make computations as simple as possible. That's where things get a little dicey. So for this example here, notice that, and I'm going to write this beside it. So B is at point A comma B. You're like, wait a minute, we've been talking. You're throwing more numbers at me. Well, I apologize. So one of our vertices, A, is 0, 0. Notice it's at the origin. So what they're doing in this situation here, they're counting left to right in terms of A and up and down in terms of B. So it looks like this point B is one up, or one to the right, which is 1A, and one up, which is 1B, or AB. See here, it is, so right here is the middle. C is 2 points away from the origin, so 1A, 2A. And notice it didn't go up and down, so its y value is 0. So we went to the right 2, or 2A, as they say here, and then we didn't go up or down, so it's 0. A little bit different. I apologize. As I've always tell you guys, I didn't create it, so I'm just delivering it. Don't shoot the messenger. So let's go to example 2. All right, so they're asking for the missing coordinates of isosceles triangle RST. So isosceles is important. So we know these two guys are the same, or congruent, so they're the same distance. Excuse me. So notice here, R is to the left of the origin, so it's a negative number, and we're still counting left to right in terms of A. Okay. And then, so S is above the origin, so it didn't move left to right. There's your X, but it looks like up and down is again in terms of B. And I wrote this in a paragraph form, but it's really what you want to, what we're doing here. So we're counting left to right in terms of A. All right, so R, negative 2A, and then we don't know the Y. Well, it didn't move up or down. It's on the X-axis, so that Y value is going to be 0. So S is on the X-axis. It didn't move left to right, but it did go up 1, or B. And then over here, T, so see, these are the same distance. So this guy was 2A. This is going to be 2A. So, but it's positive. So 1A, 2A. It didn't go up and down, so the Y coordinate is 0. I just want to point out, so SR is congruent to ST because these are isosceles triangles. So we see that this guy was 2 away. This one would be 2 away. it splits they use the origin as the center, so we know. Let's see, give me just a second. So we know, because that's the center. Okay, let's go down to the example 2 check. All right, so name the coordinates. Isosceles right triangle. So here's where I'm going to help you. This is a 90. So that makes, so if this is your 90, these are your base angles that are, mean these two sides are congruent. So there's my hint for you. And again, so we're going to I'm just going to say, yeah, it says with BC is A units long. So you can say B or just flip it because it's the same length. If you want to do it, you can say you count left to right in A and up and down also in A. So just, 1A, 2A, 3A, negative 1A, negative 2A, 1A, 2A, negative 1A, negative 2A, that sort of thing. Hopefully I didn't confuse you. I'm trying not to give the answer, but I'm trying to get you in that direction. All right, back side of the page. Oh, goodness. This is the pits. Yeah. All right, so I'm going to do the painful one. I cut down the writing in class because as long as everybody was following along, but I'll do it all here. Of course, the check below you guys are going to do. So, all right. So example 5, the Polynesian Triangle is a triangle formed between the 3 Pacific island groups that form the South Pacific region known as Polynesia. The approximate coordinates in latitude and longitude on each vertex are Auckland, New Zealand, Honolulu, Hawaii, and Easter Island, and those coordinates are given. We're going to use coordinate geometry to determine the type of triangle formed. Okay, so this is one good thing, this is a different type of exercise, so, and I know ahead of time what the answer is, so this is going to help too. So we're going to check the distance from A to H, then from A to E, and then from H to E. I'm going to do this a little different because I've already worked the problem, but if I were doing this and leaving it for you, I would set up H to be your X1, Y1, A to be the X2, Y2 for this, for it to be the X2, Y2 over here, and then obviously you just, A is your 1s, E is your 2s, but again, we're going to do the whole thing, so I'm going to start with AH. Now again, the distance formula, it's on the other side if you need to pause it. X sub 2 minus X sub 1 squared plus Y sub 2 minus Y sub 1 squared. These numbers are big. Big numbers squared make even bigger numbers, so just hang with me. So, starting with our x's, so 21.3 minus negative, so that's 2 negatives. So we're going positive plus 40.9. So, all right, then the y's, negative 157.9 minus 174.9. Of course, these are squared. All right, you got to trust me on the math. So the left side gives us 62.2. We're going to square that. The right side gives us negative 338.8. We're going to square that. And of course, the negative is going to turn positive. So on one side, we're going to have 0.84 plus 110,755.84. Oops. We add those two together, we get 114,624.68. And you take the square root of that, and you get approximately, let's just do this so we don't get confused. The square root of 114,624.68 is approximately 338.56. So we round it up here. So that's the length of AH. And we could leave it at this, because if you see three numbers, even though we're taking the square root, if it's not the same, when you take the square root, it won't be the same either. So there's that. All right, so we did AH. So let's do AE. So here I made my x1, y1, x2, y2, x2, y2, and then I'm going to switch it. So again, it's however you want to do it, as long as you use whatever coordinate. If this is your x1, this is your y1. If this is your x2, this is your y2. Don't flip-flop those. That's where you get the wrong answer. All right, so let's do AE. So that's negative 27.1 minus, let's see, hold on. Where am I at? Oh, yeah, that's the 2. Minus, so minus negative 40.9. Wait a minute, hold on. Oh, sorry. I got a text from Mrs. Whitlock. She's almost here with the groceries. There's your bonus word for this video, groceries. I'm going to have to pause and go help her in just a moment. I apologize. I'm going to pause here. I am going to finish the math for AE as it's paused, so I'll be back in just a moment. Okay. Sorry about that. So the math wasn't working, so I had to take a second anyway. All right, so coordinates, negative 27.1 minus negative 40.9, so we add here, get 13.8, we're going to square that and get 190.44. So over here, the other two coordinates, negative 109.4 minus 174.9, gives us negative 284. Okay, sorry. So these two guys make negative 284.3. We square that, we get 80,826.49. Add those two together, we get 810,000, excuse me. Wait a minute. No, I'm sorry, 81,016.93. And that's approximately 284.63. So these two are not equal. That's AH and AE. So these two weren't. So let's see if this is, to see what kind of triangle we have. So yeah, we'll just go up here. We'll say it's HE. And so this one is negative 27.1 minus 21.3. So there, squared. I'm gonna, I didn't leave enough space, so we're gonna go plus. So this is the continuation of this up here. The y's are negative 109.4 minus 157.9. So let's move all this over here. We get, so that's negative 48.4 squared plus negative, hold on. Yeah, I do think my math is wrong on my paperwork here. Yeah, give me 1 second. That's definitely not right. So I knew the numbers didn't look right before, but that's all right. So 109.4 negative. Let me just do. All right, let's just put this over here. So minus 157.9. So that gives us negative 267.3. Yeah, my notes, I had something else. So we're going to square that. Square. What did I just... Hold on. Oh. Yeah, square it. All right, so this side, well, I know this side's right. It was 2342.56, and this one's negative 71,449.29. So we're going to add the 2342. Actually, no, it won't be negative. Good catch, you guys. So yeah, don't do that. So 71. Oops. So those two guys together make square root of 73,791.85, which is going to be approximately, which I'm glad you guys get to see this. So square root equals, so it's going to be approximately 271.65. All right, let me get this guy out of the way. So now we have all three. Even though these are close, I thought for sure those might be, but they're not. So all three sides are not congruent. So what does that make triangle HAE? And this is not one we talk about a lot, but one where all three sides are not equal. It is a scalene triangle. So there's your answer. Sorry, let me back it up so you can see everything. Okay, example 5 check. We're going to finish the video off here. Hopefully, I had to pause a couple of times. That's never usually good for me, but here's hoping. All right, so this is your example check. Got your coordinates. They want you to know, they want to know what type of triangle is made right here. Now, one thing, so I did forget with scalene. Hold on, what is it? So this one here, all three sides are not going to be the same here, but it's not a scalene triangle. You're going to find out that this is, and I'm going to refer you back for just a second because this is not in the notes here. I mean, yes, you know that a squared plus b squared equals c squared. You know that's Pythagorean Theorem. And what is that? It's a right triangle. Okay? But what if a squared plus b squared is greater than c squared? Well, because if two of the sides, the a side and the b side, are way longer than c, you get an acute triangle. I didn't draw it right. But if a squared plus b squared is less than c squared, you have an obtuse triangle. So hopefully you didn't write this, but if you did, it's fine. Use the distance formula to find your three sides and then tell us what type of triangle. It's going to be one of these three. All right, practice for this one. 1 through 12. And at the bottom, the summary. So what formula can be used on the coordinate plane to verify a right triangle? So I kind of knew this was coming, and that's what that is. So it's the Pythagorean Theorem. Which is a squared plus b squared equals c squared, and it's to verify a right triangle. They kind of skipped that in the lesson, so that's why I'm bringing it in here now. And then how can you use the distance formula to classify a triangle? And it's, you use it to measure the side lengths, and that's how you determine what type of triangle you have. So if you have any questions, let me know. Until next time, have a good night.